Here we're going to look at multiple boundary lines, which you may think will give multiple regions, but in actual fact, they will just give us a single region, as we will see. So here we've got three inequalities. Our first one is x less than 4. So the boundary line is x equals 4, which is a vertical line, as you can see on the diagram. Our second region, y, is greater than -2, so our boundary line is y equals -2, which is a horizontal line, as you can see on the diagram. And thirdly, x is greater or equal to y becomes x equals y, and that's the same as y equals x. And so as you can see, we have three boundary lines there, and now those three boundary lines trap the region that we want, which is inside the boundary lines. Okay, so actually the region that we require with multiple boundaries becomes self-evident because the boundary lines trap the region inside. One last detail to look at is, should those boundary lines be full lines or broken lines? Well, the only boundary line that needs to be a full line is the one which has an inequality or equals to, and then we shade that particular boundary line in. So that is the region that we require. Similarly, in example number 2, first boundary line is x equals -2, which is a vertical line, as you can see on the diagram. Our second boundary line is y equals 6, which is that horizontal line. And our final boundary line is y equals x plus 1, which is that line there. Once again, you can see the three boundary lines trap the region in the middle, so we shade that region. And because inequality allows for x to equal 2, we shade the x equals -2 boundary line in, so that's that vertical bit there of the region. And that's how we trap our region with multiple boundary lines.